Here we go. Lesson 11.6 of the volume of pyramids and cones. And we have just one formula that, again, guides this lesson, just like the last. V is equal to capital V is equal to 1/3 capital BH. Okay? Capital B, the area of the base. Height, the altitude. Okay? So, here's how it works. Let's go ahead and little auto shape feature. I'm going to draw a rhombus, the best of our ability, because we're going to make a square pyramid here. Okay? So, from the middle of that, I'm going to just take a point to the top. And I'm going to take above it. And then I'm just going to connect every single vertex. Oops. Oh, no. There we go. Goodness. There we go. To connect every single vertex directly. And then I have this altitude height right there. Okay? And that is an altitude. That altitude is 2.4 meters. And then we're going to have this side length of 4 meters. And again, this is a square pyramid. Okay? So, the volume. Let's do it. It's equal to 1/3 capital B. And B, in this case, it's a square. So, it's going to be equal to 4 squared, right? Side times side, which is 16. So, 1/3 of 16 times 2.4. Punch it into the calculator. And we're going to have our first result so far. 16 times 2.4. We're going to divide it by 3. Like multiplied by 1/3 is 12.8. And that'll be 12.8 meters cubed. All right. Next, let's find the volume of this oblique. Ooh, yeah. All right. So this is going to be kind of a trickier one to draw. We're going to draw still a hexagon, but ooh, look at how it does that. All right. Yeah, I'm going to take this guy. I'm going to kind of shrink him. So it's not a regular. It's done like this, right? So it's for a matter of perspective. So then I just create a point above it, and then I connect every vertex to that point. You guys are much better at these directed draws than I am, okay? Now, I'm going to make it an oblique, so let's do that again. Ready? I'm going to draw it not here, but I'm going to draw this point right over here. Now let's try. Draw. Connect every single one of these vertices, okay? So, what I will give is that this height right here, this altitude height, is going to be 20 centimeters. And then this is a regular hexagon, matter of perspective, with a side of 12 centimeters. So 20 centimeters, 12 centimeters. And we're going to find the volume. All right, here it is. What's our formula? Nothing other than V is equal to 1/3 capital BH. And the fun of this problem is finding the area of the base, right? Because we now need to find the area of a hexagon, which is 1/2 of the perimeter times the apothem, going back 2 lessons, right? So, perimeter. We already know 6 sides times 12, length of 12. 6 times 12 is 72. And now we need to find the apothem. Ooh, goodness. So that is the fun in this one. All right. So let's actually take this triangle that I'd have right in here. Now, if I do this, think about it. I've got this guy. And then I'm going to have a side of 6, right? Because the entire thing here was 12. So it's a perpendicular bisection. I need to find my apothem. So I need to figure out what this degree measure is here. Now, we did this earlier in the last couple lessons ago. And here's a fun way to do this guy, to figure out this one, which I could say that it's 360 divided by 6 because it's a hexagon, right? There's going to be 6 of these, right? Right? Go ahead and erase those, or it gets too muddied of a drawing. But I do want to show my little right triangle in there, which is going to be 60. And then I could just take the 60 and divide by 2 to get 30 degrees, which is going to be this angle right there. And if that's 30, this has to be 60, making this a 30, 60, 90. So if this is 6, this guy is going to be times 2, 12. The apothem then would be equal to 6 rad 3. Okay? Fun times. Now let's take that apothem. Ooh, I need to plug it in here. So, 1/2 of 72, which is 36, times 6 rad 3. 36 times 6. What are you, 36 times 6? Tell me, calculator. 216. All right. So, this. Oops. This. It's going to get plugged in right there. It was circuitous, right? 1/3 of 216 rad 3, and then times the height, which is going to be that 20, goes in here. All right. So 1/3, 216 rad 3 times 20. Okay. And 1/3 of 216, well, we just multiplied times 3. This is going to be 72 rad 3 times 20. And then I got to plug that into my calculator one more time. Okay, so 72 times 20, which is going to give me 1440. And of course, it's 1440 rad 3. Centimeters cubed. All right, good times. Another example, we have a square pyramid. Has a height of 12 centimeters and a volume of 64 cubic centimeters. We find the side length of the square base. All right. It's going to be a fun one. Because if we go into the formula, we already had a lot of the stuff. V is equal to capital 1 equal to 1/3 capital BH, but we have the volume already at 64. Cool. So 64 equals 1/3 capital B. Okay. Now remember what capital B is. And again, it's give us this height of 12. So we already have this. And then we have to say, oh yeah, what is B equal to? Well, it's going to be side squared, right? So if I go from here, I'm going to just, I'm look for that side length. So we're going to say, okay, let's do some algebra. Well, this doesn't give me a 4. So I'm going to 64 is equal to 4 capital B divided by 4 divided by 4. Move that out. 64 divided by 4 is 16 is equal to capital B, which we know that capital B is really equal to side squared. So we're going to take a square root of each side. So I'm going to have a side of 4, right? Not plus or minus. Has to be positive. Last example. Here we go. We're going to find the height of the triangular pyramid. I got to draw a little bit. All right. First, we're going to be given as the volume is 384 meters cubed. Okay. Here's my little triangle, which I have a top right here. I'm going to connect my vertices all to it. Okay. And I have a right angle here, but here's my height. Okay. This is the height that I'm looking for. Now, everything else is going to be determined. This right angle right here, height of the triangle that's the base is 8 meters. And we have 24 as this length across the bottom. So we're going to say V is equal to 1/3 capital BH, right? Now, how do we solve? Well, we're going to take this and plug it in. So we have 384 is equal to 1/3. All right. and then the length, the area of the bottom, the area of that base is going to be 1/2 of lowercase bh, right? Base times height for the triangle. And then I need this h. That's a separate h. It's the one that I'm solving for this problem. Okay? So 384 is equal to 1/3. That's 1/2 times b times 24 is my base times my height of that lower triangle is 8 times that h. And now I got to do some algebra, right? Or do some arithmetic, that is. So let's get rid of this 1/3 in a moment. 1/2 of 24 is 12 times 8 times this h. I'm going to multiply times 3 to get rid of all that stuff maybe in a sec. Or, there's a lot of ways I can go about this. I can go with 384 and 1/3, 12 times 8, right? It's just going to be 96 divided by 3. Okay. Which 96 over 3 is 32 according to the calculator. So 384 is equal to 32h divided by 32 on both sides. And we will find that height by just taking 384 and dividing by 32. Easy. 12. Oh, nice. Calculator makes it all easy. I know it looks like a complicated problem, but arithmetic actually isn't that crazy. Because the calculator can do it, right? It's the levels of the playing field, so it's just 12 meters. That's it. Thanks, Saintsman. Good luck.